Biology of Belief continued. Introduction. The magic of cells. I was 7 years old when I stepped up onto a small box in Mrs. Novak's second grade classroom, high enough to plop my eye right onto the lens and eyepiece of a microscope. Alas, I was too close to see anything but a blob of light. Finally, I calmed down enough to listen to instructions to back off from the eyepiece. And then it happened, an event so dramatic that it would set the course for the rest of my life. A paramecium swam into the field. I was mesmerized. The raucous din of the other kids faded, as did the back-to-school smells of freshly sharpened pencils, new waxy crayons, and plastic Roy Rogers pencil cases. My whole being was transfixed by the alien world of this cell that, for me, was more exciting than today's computer-animated special effects movies. In the innocence of my child mind, I saw this organism, not as a cell, but as a microscopic person, a thinking, sentient being. Rather than aimlessly moving around, this microscopic, single-celled organism appeared to me to be on a mission, though what kind of mission I didn't know. I quietly watched over the paramecium's shoulder as it busily comported itself in and around the algal mat. While I was focusing on the paramecium, a large pseudopod of a gangly amoeba began to ooze into the field. Just then, my visit to this Lilliputian world ended abruptly when Glenn, the class bully, yanked me off the step and demanded his turn at the microscope. I tried to get Mrs. Novak's attention, hoping that Glenn's personal foul would get me another minute at the microscope free throw line. But it was just minutes before lunchtime, and the other kids in line were clamoring for their turn. Immediately after school, I ran home and excitedly relayed my microscopic adventure to my mother. Using my best second-grade powers of persuasion, I asked, then begged, then cajoled my mother into getting me a microscope, where I would spend hours mesmerized by this alien world I could access via the miracle of optics. Later, in graduate school, I advanced to an electron microscope. The advantage of an electron microscope over a conventional light microscope is that it is 1,000 times more powerful. The difference between the two microscopes is analogous to the difference between the 25-cent observation telescopes used by tourists to observe scenic vistas and the orbiting Hubble telescope that transmits images of deep space. Entering the electron microscopy suite of a laboratory is a rite of passage for aspiring biologists. You enter through a black revolving door, similar to the ones separating photographic darkrooms from illuminated work areas. I remember the first time I stepped into the revolving door and began to turn it. I was in darkness between two worlds, my life as a student and my future life as a research scientist. When the door completed its rotation, I was deposited into a large, dark chamber, dimly lit by several red photographic safe lights. As my eyes adapted to the available light, I gradually became awed by what stood before me. The red lights were reflecting eerily off the mirrored surface of a massive, foot-thick chromium steel column of electromagnetic lenses that rose to the ceiling in the center of the room. Spreading out on either side at the base of the column was a large control console. The console resembled the instrument panels of a Boeing 747, filled with switches, illuminated gauges, and multicolored indicator lamps. Large tentacle-like arrays of thick power cords, water hoses, and vacuum lines radiated from the base of the microscope like taproots at the base of an old oak tree. The sound of clanking vacuum pumps and the whir of refrigerator water recirculators filled the air. For all I knew, I had just emerged on the command deck of the USS Enterprise. Apparently, it was Captain Kirk's day off, for sitting at the console was one of my professors, who was engaged in the elaborate procedure of introducing a tissue specimen into a high vacuum chamber in the middle of the steel column. While the minutes passed, I experienced a feeling reminiscent of the day in second grade when I first saw a cell. Finally, a green fluorescent image appeared on the phosphor screen. The presence of darkly stained cells could barely be discerned in the plastic sections, which were enlarged to about 30 times the original size. Then the magnification was increased, one step at a time, first 100 times, then 1,000 times, and then 10,000 times. When we finally hit warp's drive, the cells were magnified in over 100,000 times their original size. It was indeed Star Trek. But rather than entering outer space, we were going deep into inner space, where no man has gone before. One moment I was observing a miniature cell, and seconds later I was flying deep into its molecular architecture. My awe at being at the edge of the scientific frontier was palpable. So was my excitement when I was made honorary co-pilot. I made my hands on the controls so that I could fly over the alien cellular landscape. My professor was my tour guide, pointing out notable landmarks. Here's a mitochondrion. There's the Golgi body. Over there's the nuclear pore. This, in a collagen molecule, that's a ribosome. Most of the rush I experienced came from my vision of myself as a pioneer, traversing territory that I have never been seen by human eyes. While the light microscope gave me an awareness of cells as sentient creatures, it was the electron microscope that brought me face to face with the molecules that were the very foundation of life itself. I knew that buried within the cytoarchitecture of the cell were clues that would provide insight into the mysteries of life. For a brief moment, the microscope's portholes became a crystal ball. In the eerie green glow of its fluorescent screen, I saw my future. I knew I was going to be a cellular biologist whose research would focus on scrutinizing every nuance of the cell's ultrastructure to gain insights into the secrets of cellular life. As I had learned early on in graduate school, the structure and function of biological organisms are intimately intertwined. By correlating the cell's microscopic anatomy with its behavior, it was sure to gain insight into the nature of nature. Throughout graduate school, postdoctoral research, and into my career as a medical school professor, my waking hours were consumed by explorations into the cell's molecular anatomy. For locked within the cell's structure were the secrets of its functions. My exploration of the secrets of life led me into a research career studying the character of cloned human cells grown in tissue culture. 10 years after my first close encounter with an electron microscope, I was a tenure faculty member at the prestigious University of Wisconsin School of Medicine, internationally recognized for my research on cloned stem cells and honored for my teaching skills. I had graduated to a more powerful electron microscopes that allowed me to take three-dimensional CAT scan-like rides through organisms where I came face to face with the molecules that are the very foundation of life itself. Though my tools were more sophisticated, my approach hadn't changed. I had never lost my 7-year-old conviction that the lives of the cells I studied had purpose. Unfortunately, I had no such conviction that my own life had a purpose. I didn't believe in God, though I confess that on occasion I entertained the notion of a God who ruled with an extremely honed, perverse sense of humor. I was, after all, a traditional biologist from whom God's existence is an unnecessary question. Life is the consequence of blind chance, the flip of a friendly card, or, to be more precise, the random shake of genetic dice. The motto of our profession since the time of Charles Darwin has been, God We don't need no stinking God. It's not that Darwin denied the existence of God. He simply implied that chance, not divine intervention, was responsible for the character of life on Earth. In his 1859 book, The Origin of Species, Darwin said that individual traits are passed from parents to their children. He suggests that hereditary factors passed from parent to child control the characteristics of an individual's life. That bit of insight set scientists off on a frenzied attempt to dissect life down to its molecular nuts and bolts. For within the structure of the cell was to be found the heredity mechanism that controlled life. The search came to a remarkable end 50 years ago when James Watson and Francis Crick described the structure and function of the DNA double helix, the material of which genes are made. Scientists finally figured out the nature of the hereditary factors that Darwin had written about in the 19th century. The tabloids heralded the brave new world of genetic engineering with its promise of designer babies and magic bullet medical treatments. I vividly remember the large block print headlines that filled the front page on the memorable day in 1953. Secret of Life Discovered. Like the tabloids, biologists jumped on the gene bandwagon. The mechanism by which DNA controls biological life became the central dogma of molecular biology, painstakingly spelled out in textbooks. In the long-running debate over nature versus nurture, the pendulum swung decidedly to nature. At first, DNA was thought to be responsible only for our physical characteristics, but then we started believing that our genes control our emotions and behaviors as well. If you're born with a defective happiness gene, you can expect to have an unhappy life. Unfortunately, I thought I was one of those people victimized by a missing or mutant happiness gene. I was reeling from a relentless barrage of debilitating emotional roundhouse punches. My father had just died after a long, painful, fraught battle with cancer. I was his principal caretaker and had spent the previous 4 months flying back and forth between my job in Wisconsin and his home in New York every 3 to 4 days. In between stays at his deathbed, I was trying to maintain a research program, teach, and write a major grant renewal for the National Institutes of Health. To further compound my stress levels, I was in the midst of an emotional draining and economically devastating divorce. My financial resources were rapidly depleted as I tried to feed and clothe my new dependents, the judicial system. Economically challenged and homeless, I found myself living pretty much out of a suitcase in a most abysmal garden apartment complex. Most of my neighbors were hoping to upgrade their lives' standards by seeking accommodations in trailer parks. I was particularly scared of my next-door neighbors. My apartment was broken into, and my new stereo system was stolen in my first week of residence. A week later, 6-foot-tall, 3-foot-wide Bubba knocked on my door, holding a quart of beer in one hand and picking his teeth with a 10-penny nail held in the other. Bubba wanted to know if I had the directions for the tape deck. The nadir was the day I threw the phone through the glass door of my office, shattering the Bruce H. Lipton, Ph.D., Associate Professor of Anatomy, UW School of Medicine, sign, all the while screaming, "Get me out of here!" My meltdown was precipitated by a phone call from a banker who politely but firmly told me that he couldn't approve my mortgage application. It was like the scene from Terms of Endearment when Deborah Winger aptly responds to her husband's hopes for tenure. "We don't have enough money to pay the bills now. All tenure means is we won't have enough money forever." The magic of cells, déjà vu. Luckily, I found an escape in the form of short-term sabbatical at a medical school in the Caribbean. I knew all my problems would not disappear there, but as the jet broke through the gray cloud cover over Chicago, I felt it that way. Oh. Let's try that again. But as the jet broke through the gray cloud cover above Chicago, it felt that way. I bit the inside of my cheek to prevent the smile on my face from evolving into audible laughter. I felt as joyful as my 7-year-old self first discovering my life's passion, the magic of cells. My mood lifted even more on the 6-passenger commuter plane that took me to Montserrat, a mere 4-by-12-mile dot in the Caribbean Sea. If there ever was a Garden of Eden, it probably would have resembled my new island home, erupting out of the sparkling aquamarine sea like a giant multifaceted emerald. When we landed, the gardenia-laced, balmy breezes that swept the airport's tarmac were intoxicating. The native custom was to dedicate a sunset period as a time of quiet contemplation, a custom I readily adopted. As each day wound down, I looked forward to the heavenly light show. My house, situated on a cliff 50 feet above the ocean, faced due west. A winding path through a tree-covered fern grotto led me down to the water. At the bottom of the grotto, an opening through a wall of jasmine bushes revealed a secluded beach where I enhanced the sunset ritual by washing away the day with a few laps in the warm, gin-clear water. After my swim, I would mold the beach sand into a comfortable recliner, sit back, and watch the sun set slowly into the sea. On that remote island, I was out of the rat race and free to see the world without the blinders of civilization's dogmatic beliefs. At first, my mind was constantly reviewing and critiquing the debacle that was my life. But soon, my mental Siskel and Ebert ceased their thumbs up, thumbs down review of my 40 years. I began to re-experience what it was like to live in the moment and for the moment, to become reacquainted with sensations last experienced as a carefree child, to feel again the pleasure of being alive. I became more human and more humane while living in that island paradise. I also became a better cell biologist. Almost all of my formal scientific training was in sterile, lifeless classrooms, lecture halls, and laboratories. However, once I was immersed in the Caribbean's rich ecosystem, I began to appreciate biology as a living, breathing, integrated system rather than a collection of individual species sharing a piece of the Earth's turf. Sitting quietly within the garden-like island jungles and snorkeling among the jeweled coral reefs gave me a window into the island's amazing integration of plant and animal species. All live in a delicate, dynamic balance, not only with other life forms, but with the physical environment as well. It was life's harmony, not life's struggle. That sang out to me as I sat in the Caribbean Garden of Eden. I became convinced that contemporary biology pays too little attention to the important role of cooperation because its Darwinian roots emphasize life's competitive nature. To the chagrin of my U.S. faculty colleagues, I returned to Wisconsin, a screaming radical bent on challenging the sacred foundational beliefs of biology. I even began to openly criticize Charles Darwin and the wisdom of his theory of evolution. In the eyes of most other biologists, my behavior was tantamount to a priest bursting into the Vatican and claiming the Pope was a fraud. My colleagues could be forgiven for thinking a coconut had hit me on the head when I quit my tenure position and fulfilling my life's dream to be in a rock and roll band, took off on a music tour. I discovered Yanni, who eventually became a big celebrity, and produced a laser show with him. But it soon became clear that I had a lot more aptitude for teaching and research than I did for producing rock and roll shows. I wound down my midlife crisis, which I'll describe in more agonizing detail in a later chapter, by giving up the music business and returning to the Caribbean to teach cell biology again. My final stop in conventional academia was at Stanford University School of Medicine. By that time, I was an unabashed proponent of new biology. I had come to question not only Darwin's dog-eat-dog version of evolution, but also biology's central dogma, the premise that genes control life. That scientific premise has one major flaw. Genes cannot turn themselves on or off. In more scientific terms, genes are not self-emergent. Something in the environment has to trigger gene activity. Though that fact had already been established by frontier science, conventional scientists, blinded by genetic dogma, had simply ignored it. My outspoken challenge of the central dogma turned me into even more of a scientific heretic. Not only was I a candidate for excommunication, I was now suitable for burning at the stake. In a lecture during my interview at Stanford, I found myself accusing the gathered faculty, many of them internationally recognized geneticists, of being no better than religious fundamentalists for adhering to the central dogma despite evidence to the contrary. After my sacrilegious comments, the lecture room erupted into shouts of outrage that I thought meant the end of my job application. Instead, my insights concerning the mechanics of a new biology proved to be provocative enough to get me hired. With the support of some eminent scientists at Stanford, especially from the pathology department's chairman, Dr. Klaus Bench, I was encouraged to pursue my ideas and apply them to research on cloned human cells. To the surprise of those around me, the experiments fully supported the alternative view of biology that I was postulating. I published 2 papers based on this research and left academia, this time for good. I left because, despite the support I got at Stanford, I felt that my message was falling on deaf ears. Since my departure, new research has consistently validated my skepticism about the central dogma and the primacy of DNA in controlling life. In fact, epigenetics, the study of the molecular mechanisms by which environmental controls genes activity, is today one of the most active areas of scientific research. The newly emphasized role of the environment in regulating gene activity was the focus of my cell research 25 years ago, long before the field of epigenetics was ever established. Lipton, 1977a, 1977b. While that is gratifying for me intellectually, I know that if I were to teach and researching in a medical school, my colleagues would be still wondering about those coconuts because in the last decade, I have become even more of a radical by academia's standards. My preoccupation with a new biology has become more than an intellectual exercise. I believe that cells teach us not only about the mechanisms of life, but also teach us how to live rich, full lives. In ivory tower science, that kind of thinking would no doubt win me the wacky Dr. Dolittle Award for anthropomorphism, or more precisely, cytopomorphism. Thinking like a cell. But for me, it's a biology 101. You may consider yourself an individual, but as a cell biologist, I can tell you that you are in truth a cooperative community of approximately 50 trillion single-celled citizens. Almost all the cells that make up your body are amoeba-like, individual organisms that evolved a cooperative strategy for their mutual survival. Reduced to basic terms, human beings are simply the consequence of collective amoebic consequences. Human beings are simply the consequence of collective amoebic consciousnesses. As a nation reflects the traits of a citizen, our humanness must reflect the basic nature of our cellular communities. Living the lessons of cells. Using these cell communities as role models, I came to the conclusion that we are not victims of our genes, but masters of our fates, able to create lives overflowing with peace, happiness, and love. I tested my hypothesis in my own life after a nudge from my audiences, who asked me why my insights hadn't made me any happier. They were right. I needed to integrate my new biological awareness into my daily life. I knew I had succeeded when, on a bright Sunday morning in the Big Easy, a coffee shop waitress asked me, "Honey, you are the happiest person I ever did see. Tell me, child, why are you so happy?" I was taken aback by her question, but nevertheless I blurted out, "I'm in heaven." The waitress shook her head from side to side, mumbling, my, and then proceeded to take my breakfast order. Well, it was true. I was happier. I was happier than I had ever been in my life. A number of you critical readers may rightly be skeptical of my claim that earth is heaven. For, by definition, heaven is also the abode of the deity and the blessed dead. Did I really think that New Orleans or any other major city could be part of heaven? Ragged homeless women and children living in the alleys, air so thick that one could never know if stars really existed, rivers and lakes so polluted that only unimaginable scary life forms could exist in them. This earth is heaven? The deity lives here? He knows the deity? The answers to those questions are yes, and I believe I do. Well, to be completely honest, I must admit that I don't know all of the deity personally, for I don't know all of you. For God's sake, there are over 6 billion of you. And to be more fully honest, I don't really know all of the members of the plant and animal kingdom either. Though, I believe they also comprise God. In the immortal words of Tool Time's Tim Taylor, back the truck up. Is he saying that humans are God? Well, yes, I am. Of course I am not the first to have said this. It is written in Genesis that we are made in the image of God. Yes, this card-carrying rationalist is now quoting Jesus, Buddha, and Rumi. I have come full circle from reductionist, scientific take on life to a spiritual one. We are made in the image of God, and we need to put spirit back into the equation when we want to improve our physical and our mental health. Because we are not powerless biomechanical machines. Popping a pill every time we are mentally or physically out of tune is not the answer. Drugs and surgery are powerful tools when they are not overused, but the notion of simple drug fixes is fundamentally flawed. Every time a drug is introduced into the body to correct function A, it inevitably throws off function B, C, or D. It is not gene-directed hormones and neurotransmitters that control our bodies and our minds. Our beliefs control our bodies, our minds, and thus our lives. O ye of little belief. The light outside of the box. In this book, I will draw the proverbial line in the sand. On one sided line is a world defined by neo-Darwinism, which casts life as an unending war among battling biochemical robots. On the other side of the line is the new biology, which casts life as a cooperative journey among powerful individuals who can program themselves to create joy-filled lives. When we cross that line and truly understand the new biology, we will no longer fractiously debate the role of nurture and nature, because we will realize that the fully conscious mind trumps both nature and nurture. And I believe we will also experience as profound a paradigmatic change to humanity as when a round world reality was introduced to a flat world civilization. Humanities majors who may be worried that this book offers an incomprehensible science lecture have no fear. When I was an academic, I chafed at the three-piece itchy suit, the constricting tie, the wingtip shoes, and the interminable meetings, but I love to teach, and in my post-academia life, I've gotten plenty of teaching practice. I presented the principles of the new biology to thousands of people all around the world. Through those lectures, I have honed my presentation of the science into easy-to-understand English illustrated by colorful charts, many of which are replicated in this book. In Chapter 1, I discuss smart cells and why they can teach us so much about our own minds and bodies. In Chapter 2, I lay out the scientific evidence to show you that genes do not control biology. I also introduce to the exciting discoveries of epigenetics, a new field of biology that is unraveling the mysteries of how the environment, nature, influences the behavior of cells without changing the genetic code. It is a field that is uncovering new complexities in the nature of disease, including cancer and schizophrenia. Chapter 3 is all about the cell's membrane, the skin of the cell. You no doubt have heard more about the DNA-containing nucleus of the cell than you have about its membrane, but frontier science is revealing in ever greater detail what I concluded over 20 years ago, that the membrane is the true brain of the cellular operation. In Chapter 4, I talk about the mind-bending discoveries of quantum physics. Those discoveries have profound implications for understanding and treating disease. However, the conventional medical establishment has not yet incorporated quantum physics into its research or medical school training, with tragic results. In Chapter 5, I explain why I named this book The Biology of Belief. Positive thoughts have a profound effect on behavior and genes, but only when they are in harmony with subconscious programming. And negative thoughts have an equally powerful effect. When we recognize how these positive and negative beliefs control our biology, we can use this knowledge to create lives filled with health and happiness. Chapter 6 reveals why cells and people need to grow and how fear shuts down that growth. Chapter 7 focuses on conscious parenting. As parents, we need to understand the role we play in programming our children's beliefs and the impact those beliefs have on our children's lives. This chapter is important whether you are a parent or not, for as a former child, the insight into our programming and its impact upon our lives is quite revealing. In the epilogue, I review how my understanding of the new biology led me to realize the importance of integrating the realms of spirit and science, which is a radical shift from my background as an agnostic scientist. Are you ready to use your conscious mind to create a life overflowing with health, happiness, and love without the aid of genetic engineers and without addicting yourself to drugs? Are you ready to consider an alternate reality to that provided by the medical model of the human body as a biochemical machine? There is nothing to buy, and there are no policies to take. It is just a matter of temporarily suspending the archaic beliefs you have acquired from the scientific and media establishments so that you can consider the exciting new awareness offered by leading-edge science.